So, all right, let's have a quick start because I have a 45-minute session, so I do need to power through some of these parts. And luckily, some of the parts have been shown by Mike before, which have to do more with the MP author inside building of management packs, so I could do a little bit less about that. So welcome to the session. Since today's topic is about writing management packs, I think I have something fun for you. I want to talk to you about monitoring web-based APIs through SCOM. We have a proof of concept setup, which happens to be part of my home automation setup. And we are going to monitor my Philips Hue Bridge and attach lights and sensors and show you a bit of the process in building the pack. I hope you like it. So this is the agenda for the session. We start with an introduction into the story and the device that we are monitoring. Next, we discuss how I got access to the device and how to get scripted access to the device. And we follow on the right-hand side with the SCOM management pack story by dividing into the class structure. And we talk about creating monitoring and views and tasks. So let me first introduce where I'm coming from. So Topcore is an IT consultancy based in the Netherlands with team members spread across multiple countries and delivering consultancy services to customers of all sizes and verticals, with a specialization in Microsoft monitoring and management tooling. So we are well known for our SCOM services, hence my nickname. Some of our main services are listed here, being a SCOM health check to view and confirm your current status of the SCOM environment. SCOM training at different levels from operator to admin to specialist, and of course our community efforts, such as this one. SCOM implementations, migrations, upgrades, and extending your monitoring and dashboarding, and our maintenance as a service to help keep your monitoring environment running and healthy. So a little bit about me. I think my nickname was mentioned before. I'm a 10-year Microsoft MVP for the System Center and now Cloud and Data Center Management. I'm a technical director at Topcore and my hobby is playing billiards, and that's carom billiards without holes in the sides of the table. I'm also a charity ambassador for the House of Tales dog shelter in Thailand. Though the charity is located in the Netherlands and we have a shelter in Thailand with a few other locations as well. So have a look at that. So let me introduce you to how and why I selected this topic to talk about and why this device. SCOM can talk to agents or SNMP devices, and this is not always possible with some devices you might be interested in though. So some examples are IoT devices, some medical equipment, sensors, production equipment, and so on. We saw one example earlier today through WMI. But some of these devices have an API to talk to. Some through web-based API and sometimes another kind of API or another type of access, which means that we can get access to the device somehow, which means we could monitor it. I wanted to do a proof of concept and needed a device nearby to do this. Aside from this, obviously the answer to the question, why am I doing this, is just because we can. So my home automation contains some smart light bulbs and sensors from Philips, which are all controlled by a Philips Hue Bridge. That's the thing at the bottom over there with the blue circle. It turns out that bridge has an API interface with which we can see attached items such as these light bulbs and smart sensors. So I'm using this device as a proof of concept and to simply play with. It is a simple way to showcase how to do it, and next you can do it with something else and of course make it better. So what are we talking about in short? This is a Hue Bridge, meant as a home automation bridge for you to connect to using your phone and the Hue app, so you can turn on lights and such things. The bridge can be integrated with other home automation tools as well, and I have it connected to Google Home Automation. The circle in the middle has a blue glow if it is connected. What it is mostly used with are a bunch of light bulbs which are connected to the bridge using the Zigbee protocol. So you can turn lights on and off and add different strengths and colors if the bulbs support it. Also, you can have motion sensors. I have 2 of those in my house currently, and they are meant to have the motion sensor in there, which is the big round thing in the middle, and a light intensity sensor, which is the small round thing at the top of that sensor. This is usually there's also something else hiding in there, which we will discuss in a bit as well. So this is the main setup. The bridge has an API we can talk to, as it turns out, and the rest are connected to it. So let's start talking to it. So the first challenge is getting access to a device that we know has an API. So let's have a look at what we can find. I found that there is a developer page with some public information and some for which you need to be registered. So the public page listed here has examples on how to get in and how to create what you need. So the first thing we do is we open up the mobile phone app and we go into the settings of the currently connected Hue Bridge to find an IP address. This can be seen in the middle of that block of text. The smart thing to do would be to get your DHCP to give it the same address every time it starts up. Secondly, we go to a browser and go to the address where we can find the Clip API debugger. We ignore the security warning about the HTTPS certificate for now and we run it again while trying to script against it. We can only get to this page from a local machine. Another piece of the puzzle that we need to remember. And we need to create ourselves a user string. This is a unique string created to access all the information on the device through the API for this device. It is just a set of commands to go through, which is in the guide in the link. With that, we now have an IP address and a user string, which is what we really need going forward. And we have 2 extra pieces of information which we need later. That is the certificate warning and the fact that we need to talk to the bridge from a device located on the same network. So let's do a quick demo of how we are getting access to the bridge and how to talk to it. So let me open up a browser and I have a link here for the API debugger tool. As you can see at the top, it is set to non-secure because it doesn't trust the self-signed certificate. So we will have to deal with that later. And this is basically a place where you can put in the URL and click get. If I do it right now, I just get an unauthorized user here in the output in JSON format. But if I put in the string with the user account in it, then I get a response with all kinds of stuff. So first of all, I see here lights. I see light number 1, light number 8, and so on. And if I scroll down, I get to the sensors. So here are sensors for state, presence, etc., etc. Now, if I append at the URL at the end, for example, lights, and I click the get button again, and I can scroll up, and to the top, I only get the list of lights. So again, here's light number 1, and if I scroll down, I would see light number 2. Now, if I want to get more precise, I just append one of the numbers to the end. So for example, if I append a 5 to this, then I get only one light, which is light number 5, and that is my office light. Now, if I look here at the state, it says that on is true, and indeed it is on. It is part of my home automation. I can see some software version. I can see that the type is a dimmable light, and I give it a name in Dutch. Kantoor means office. I see the manufacturer, Signify, which is a new name for Philips lighting in the Netherlands. And a bunch of other stuff that I can see. Now let me jump down into the sensors. So I put in sensors and I click get. And from here I can see several sensors. So this is sensor 1. This is a daylight sensor, which is actually not a real sensor as in that it looks for light. It actually looks at the internet configured state, what it, that you would have daylight or not. So based on the date and location, it would know if there would be daylight. And there is an offset here, an offset here of sunrise and sunset of 15 minutes. So I can let my home automation turn on the lights around the time when it turns dark and turn it back off again when it turns light. Now, if I go to a little bit down, maybe to sensor 4. So sensor 4, this is my motion sensor. This is what I was talking about in the beginning. So I have a motion sensor. It says presence is false, so there's at the moment no movement. And if I click down, I can see again the Hue motion sensor bathroom. I can see that's the type presence, and again it's a motion sensor. Now, as advertised, this motion sensor actually also has a light level sensor in it. So the next number 5 is the light level, and there's a number in here of 8000. It is somewhat connected to the amount of lumen. And well, I can see that the sensor itself is on battery and that kind of stuff. And it has a name. Actually, I found out that I needed to give the name myself in here, because in the Hue app on my phone, I can only change the motion sensor name, but not the internal sensors within the motion sensor. Now, there's one interesting thing that I found when I was scrolling this. Within the same motion sensor, there's also a temperature sensor. And this temperature sensor just gives a number in hundreds of a Celsius. So this is actually 17 degrees Celsius when some. So this was actually a surprise to me, because it's not advertised that this is also a temperature sensor, but I did find it in the blogs later. And if I scroll down a little bit more, then I will see others such as the present state. And this is like a geofence, so it actually looks for my Wi-Fi signal on my phone if it's nearby on the same network, or the GPS coordinates, so that I can have it, my automation, turn on the lights when I come home from an evening playing billiards. And so on. And if I go further down, then I will see the other motion sensor again with the light level and the temperature level. So that means that currently we have URLs from where we can determine which lights we have and which sensors we have. And when appending a specific number for one of them, we can zoom into that one object and read from it to see if a light is turned on and what the light level is from the motion sensor, for example. All right. So that means we have now a IP address, we have a user string, and we can see that we can get access to it through the debugger in the device. So what else do we need? So I have a desktop sitting in my house, which is on the local network. So that's the part of our puzzle. Remember that we needed that. I arranged that it has a SCOM agent installed on it, and that it talks to my SCOM management group. It is using a certificate trust on the agent, and it will just talk to my SCOM management group elsewhere. Now we must get the SCOM desktop agent to start talking to the Hue Bridge app. So for this we need one more step in between, and we need a scripting language. And of course, for nowadays, this is PowerShell. And we can later throw PowerShell scripts into our SCOM management pack. So let me demo what this looks like. All right, now let me pull up Visual Studio Code with a file of stuff in it that I was using while I was testing this, and to see what I needed to get this to work. So first of all, here in lines 8 and 9, I need to define where my bridge and my user ID would be, and later on I would of course just pass this as a variable to the script. So let me just run this one. Next is that I needed a way to ignore the self-signed certificate on the Hue Bridge, otherwise the connection fails. So I put in a function here which I found on the internet, so I can just, wow, I can run this part of it, and now it should ignore the self-signed certificate. Now if I scroll down a little bit more to line level 30, this is where I was going to use the PowerShell method invoke REST method. This just passes a URL, and I can pass the URL being the Hue Bridge IP API and put in the user string, and in this case I'm putting in sensors 5, which was that light level sensor in the bathroom. So if I run this to get it, then I can see, for example, if I only get this item, and I scroll down a little bit, then I get a bunch of information about this item. I can see that this is the light sensor. I can see the capabilities here. So this gets me my sensor back. And then if I want to know the light level itself, I can run this. So from the state, I'm getting the light level. And then if I open up the variable, I can see my light level here is 10,000 because it's slowly getting more light outside. Now for temperature, we can do basically the same. I have here in line 33, temperature, invoke REST method, again with the default string sensors 6, which was the motion sensors temperature sensor there. When I found the temperature, I divided by 100 to get the amount in Celsius. And then of course I can get that name again. So what I'm doing here is I'm writing the output, sensor name, light level, and temperature level. So if I just run this section again, and then look here at the bottom, this is basically what got written at the bottom. So Hue temperature sensor, bathroom, the level found in the bathroom is 10,000, the temperature found is 18 degrees Celsius. So this is how I can get information through PowerShell. I can also connect to the motion sensor. I have, for example, here also getting the whole configuration from the Hue Bridge, whereby I can get the name, the ID, software version, the model, and so on. Let me see what I wanted to look at. Line 62, that's around here. So this is a part where I wanted to get all of the sensors as part of a discovery. So if I start here from 62, you can see that I have here the sensors I'm getting for a certain type. I'm getting a sensor. Then for each sensor in the list of sensors, I'm trying to get something, and that is a name, a type, a model, manufacturer, software, and a product name. And then if it is not 0 or not applicable, then I will just list the sensor ID, name, type, product version, and so on. So if I take this from 62, to, I have to get the end here as well. And I just dump it. Then I get a list here at the bottom of these sensors. So again, here's the motion sensor, presence sensor, and then one down, there's a light sensor in the hall, and there's a temperature sensor in the hall. So this is how I get my list for my discoveries. And of course, I did give my sensors, the internal sensors at least, also a name. For example, here the temperature sensor and the light sensor. Like I said, by default, it doesn't have a specific name, and you need to name it yourself for it to become more useful after you have discovered it and you are looking in SCOM. So now I have an easier way to discover them using PowerShell, all of the components that I need. Right. So that was the second piece of information. So now we have devices, we can get to them and we can read from them. We have a SCOM agent somewhere and we have PowerShell script access to the device to list the objects and to read from each object based on its ID and type. Now we need a SCOM management pack. So this is very exciting since this day is about management packs, right? So we start with figuring out which classes that we need in our management pack. I need to have some proxy monitoring the device, and that is my desktop. So I decided to create a watcher node for this reason. I decided for myself to not try and use difficult IP scanning methods and some way of placing user strings. I just created a registry entry on my desktop which refers to the IP address of the Hue Bridge and its user string. The way I did it also suggests that there is one home to one bridge relationship, which is valid enough for most cases, but there are some which would have multiple bridges listed. So in that case, I would have need to change my methodology a little bit. Next, I needed a definition for my Hue Bridge device itself, and it is found by looking in the registry of my desktop. And if I want to discover more of it, I can connect to it with the PowerShell script and get more properties, as we have just seen. Next, we have a load of light bulbs. So I needed a class for a light. And we also saw that we have a list of sensors. So I create a class for sensor. Further down the line, I decided that I wanted to immediately discover different types of sensors and handle them differently in views and monitoring. So I could try to work with groups based on properties found of the sensor and create monitoring targeted at the sensor level and turn it on or off for that group. But I made the decision to create classes in this case for motion sensor, light level, and the temperature sensor. And we can all find them by going through the bridge sensors list and looking at the type of sensor. Now, what does this look like if we open this up in one of our favorite tools? So this is Select MP Studio. In fact, I have built the initial version of this management pack in Notepad++. And this is because I am afraid of Visual Studio and I let my Select license run out of date. Very, very, very sorry, guys. Some would say that they are more afraid of Notepad variants to create management packs, but anyway, I might just be old style. And since I used to create web pages in my student years in HTML and just using the old-fashioned Notepad without the colors. But let's be honest, have a look at Visual Studio with authoring extensions or have a very serious look at what Select products can do for you, because this has so much more value to bring to you. And you've seen just now Mike work through creating classes and discoveries really fast. So MP Author has a way to use it for free, and you can get pretty far with that. And MP Studio and the MP Author Pro offer many more extras. So after I got my license fixed, I could use MP Studio for versioning as well and adding stuff to my pack. So here we see the classes, internal names and display names. We see the base class used. For the watcher, I use the Windows computer role. And for the initial Hue components, I used logical entity. And the specific sensor classes have the Hue Bridge sensor as a base class. And on the right-hand side, we can see that several of the classes have a list of properties, such as manufacturer, name, software version, and type. The next we need are discoveries for each class. So these are the discoveries. The Watcher node discovery is simply looking at the registry of my desktop to find the entry it needs. And the other discoveries are PowerShell scripts, which look like the ones I showed you earlier. They go through, for example, the light bulbs, and for each light bulb, they collect some properties. Those all go into a property bag for every light bulb. And at the end of the script, I feed the property bag back to SCOM. This creates the discovered class objects in SCOM. This brings us to the next phase. So we have classes and discoveries. And after a few version increments in the management pack, we finally got the objects found and put in SCOM with their properties. Make no mistake, usually this takes a few iterations to get it right, but it'll work in the end. So this makes SCOM a CMDB, but we want to monitor something, right? So what do we want to know? I want to collect some performance data. To collect performance data, we use rules. They just collect something and dump it in the databases, so we can later look at them and draw graphs or reports. I want to have the on or off status of a light bulb. We can make that a 0 for on, for off, and a 1 for on. I want to have the light level too, so I can see what the light level does in general during the day. I found that hidden temperature sensor, so we can collect that one. And I want the data from that motion sensor. Now, as you can see, this has a big strike through on it. It turns out that the motion state pops up for only a few seconds as a state change, and next it places a date timestamp, which the automation uses to add a number of minutes to and turn the light off based on that timestamp and not based on the actual movement. So having a state change for only a few seconds is really hard to monitor for with SCOM while doing script calls to the interface, so I let that one go. Since I had the light of, for instance, the bathroom automated, the light bulb on or off status and the light level increase would clarify that there was motion anyway. And finally, we get to the monitors. So I went with a monitor on the temperature to make a state change if the temperature became too high. I did this before the summer arrived, and I set it to 25 to 27 Celsius as a threshold, and after a few hot days it changed state. For fun, I had added an alert and in the text that I would go to get an ice cream because it is too hot in the house to work. So the text is now gone again though. Now, what I did was I created data sources in my management pack. You can also call them module types, as they are called in the MP Author interface. There are basically my PowerShell scripts, and I can call them and pass them the right values. I created one for the light bulb, one for light level, and one for temperature. Next, I link them to the rules so that when the rule runs, it calls the data source, which runs the PowerShell script, which gets the data from the Hue Bridge. And since I have that data source talking to the temperature sensor every few minutes, I can also let my monitor set my monitor to the same interval or at a multiple of that interval. This makes it cook down. So the script actually runs once and feeds data back to both the rule and the monitor to do its thing. So we now have the class objects discovered, and some of them have performance collection on them. And there is a monitor, which can create state changes and alerts. So the next thing we need is some views in SCOM. Now let's have a look at the demo for the views. Now let's have a look at this in the SCOM console. So in the SCOM console, I created a folder with a bunch of views in it. And let's start with the Hue Bridge watcher state. So looking at this first one, I can see my watcher. This is my desktop. And of course, there's no monitoring related to this. It's just the entry is there, that I've discovered it. If I move up to the Hue Bridge state, I will see my Hue Bridge, and it has the IP address and the model and software version and where it is located. So it's located on the bridge, on the watcher. Now, if I move up again, I get to a state view for the sensors. And here's a list of sensors. So here at the top, there's the daylight sensor again. I have a dimmer switch. I have the motion sensor in the bathroom with the light and temperature sensor in here. We can see the sensor IDs, such as the ones that we have used before. We can see the type, that it's a light level or temperature type, and the other information collected. I also created a alerts view, which is now empty because there's not much to alert for right now. It's too cold. And I've created some folders with other things. So for example, here's the lights. So I have several lights listed here. Here's my office light, number 5, as we have seen before. It's a dimmable and it's a Hue white lamp in this case. And there are some other lights available here as well. And over here, I get to my light performance. So this is the first performance view where I was collecting the light level. So if I'm looking here at the office, let me take only the office for the last 2 days, for example. So you can clearly see, hey, there's a night here, there's a day when I come in the morning, and then at the end of the day, 5:30 in this case, yesterday, I went out of the office and went downstairs. So if we want to look at that, then we can actually look here at the woonkamer, which is the living room. If I look at the living room here, I can see, for example, here at the end of the day, that the living room light went on and off, and then during the evening it was turned on again for a while. And then on the next day, it was turned on early on in the morning because my wife gets up early in the morning to talk to the shelter, the dog shelter in Thailand, and you need to be early for that and to get the latest updates. And again, over here we were gone for a while. We went out last night, and then when you came back, the lights turned on in the living room again, and so on. All right, let's go to the next, to the sensors. So in this case, I already have the specific discovery for only the light level sensors. So we can see here the sensor type is light level. We have 2 of them here. One is in the bathroom, and the other one is in the hall. And there are the motion sensors, 2 of them here, and the temperature sensor state. So as you can see, this one actually has state because we are monitoring if the temperature goes above 25 or 27 degrees Celsius. And if I look here at the sensor performance view, I can see in this case both light sensors. Yes, both light sensors. The smaller one, the lower one here in green, is in the hall, and it also detects if it's turning on its own light, especially during the evening, and then you will see the spikes going up to the 10,000 level. And then the other one, the blue line, is for the bathroom sensor. So the bathroom sensor has a window, so it has more light coming in. The hall is just dark, it doesn't have its own window. And as you may be able to see, when there's enough light outside, the window of the bathroom is to the west, so it gets less light in the morning and then it gets more light in the afternoon. And the same repeats here in other day when it was a little bit darker. And also we can look at the temperature sensors during a few days here. So that is what I created for the basic views. It has alert view, state view, and performance views. All right, so that is another part of the puzzle. Now the question is, can we actually interface with some of this to adjust something? So this is where tasks come into play in SCOM. So, but what can we actually do? I'm clicking the wrong thing. Management Pack Studio at this moment. 1 second. We are looking at I'm clicking on the wrong side of the screen. So what can we do? The sensors seem to be read-only, so we cannot adjust the behavior much for those. But for a few we can make changes though through the real interfaces, such as determining when you are home. But they are not really that suitable for SCOM tasks. We could relate automations to those though in the future. Now, what about lights? We can turn lights on and off, which should not be that difficult, right? And we can dim some of the lights, we can adjust colors of the lights, and there is a possibility there to create tasks to adjust the brightness or color settings. So let's have a very short demo about that for the first option, so the lights on and off option. So we are in Management Pack Studio at this moment. We are looking at the tasks, and I have two tasks here. One is to turn on the light and one is to turn off the light. Now what these tasks are doing is that they are calling a data source. Let me try and find the data source here. In module type, there's a data source here, which is the script. So let me look at turn on the light in this case. Let me open up the XML. So let's see if I can get this bigger. I actually can get this a little bit bigger. So ignore all of the rest. So there's a PowerShell script name. I start it up. And over here I had the function to ignore self-signed certificates, but it turns out that because I'm getting so much data from this device that it will actually skip this and I don't need it. So let's move on. So the first thing that I do is I check first if the light is already turned on. So I'm going to the light ID. I'm looking for the status. If the state is on, if it's true, then I can say, all right, the light is already turned on. And otherwise, I will move forward. So what I'm doing here is I am creating a string, a message body with a small JSON on it. It says that the state on must be set to true. Now, I was using, as you can see here, the invoke res method for getting all of the states and all of the information. But when I was using this to change something on the device, it gave me so much problems that for this, I'm actually using the invoke web request. And the method is put. I'm going towards this light to the state, and I'm inserting that message body, which then turns it on. So if I have to look at this in the SCOM console, and I go to the lights, and I find my office light here, I can say, okay, turn off the light. I can run it, and sure enough, light 5 turned off, and I'm sitting in the dark. So let me click the other one quickly to turn on my light again, and now my light is turned back on. All right, so that was the last part. So now let's move on to some afterthoughts for this mini project for so far. First of all, the authoring tool. So if you're going to do a project like this for a device in your environment, it is advisable to use a real management pack authoring tool. Now, Select has a great set of tools for this, and there's also Visual Studio. For testing the PowerShell pieces, I was happy to use Visual Studio Code, which is a smaller tool and very useful for scripting and such. Now, the class structure can be different. For example, a way to have multiple bridges is possible, but we have to consider that each has a different user string. Of course, your device has different options, and it is just figuring out a decent way to do it. I'm not considering myself to be a developer, but I can still get this done. It did not take me that long actually to have the basic pieces set up. It was just solving small issues during the process, which took a few iterations of the management pack version. Next, I also want to upload this info into Azure Monitor through Log Analytics and play with it there in that dashboarding. Now, as you may be aware that I started blogging about this project as well, and I will continue the story there, including the next steps, which I basically already mentioned, the Azure Monitor and the dashboarding around that. Now, there's just one thing that I wanted to mention. For some of you who will be more involved in the SCOM environment at your organization, Topcore offers several levels of training and certification for SCOM. We are regularly running public SCOM operator trainings for a very low cost, and we will be running the SCOM admin trainings, which leads to the administrator certification badge. And following that are the specialist topics, which range from designing for complex environments, specialist monitoring features such as network and Linux and ACS, and creating management packs at different skills and tooling levels. We are working with some of our partners from the community for some of this content. So with that, now you can use the chat to send in your questions and we'll be answering them one by one. So let me jump to the relevant screen. Let's see. Let's see, from James, just so I'm clear, if your Hue monitoring example, you're using HTML response codes as your data source, as opposed to your watchers nodes WMI sim. Is that correct? Yes. So in this case, I'm not using WMI. That was what Mike was using, and that worked out pretty well as well. But since this Hue Bridge is a separate device, separate from my desktop, I can only get through it through a web-based API. So this is why I'm using PowerShell from my local desktop to connect to the machine and get all the data that I need. So this is just a different way of doing it, right? But you can see a very large overlap with what Mike was showing earlier, in also the way in building it up. And of course, you could also see that when Mike was building it, he just started with the discovery, which then created the class. And if I'm doing this manually, I needed to go the other way around, which basically takes more time. So again, use the right tooling for the right job. That might help you a lot. Let's see if there are any other related questions for me. Otherwise, I will give the presentation back to Select.
I think there's one other question. Well, I'm just looking at the comment from Chris just above the James's question.
Let's see, not a question, but related to the discovery of the hardware monitor software. I'm guessing when you check the checkbox to have the software start at startup, you likely create a registry entry, so you could use that value as your discovery criteria. Yes, I think, well, this was related to Mike's story.
Yeah.
But yes, it would create also a registry entry. So I'm guessing you could do it that way. The only thing is that you need to be sure that the software is running, otherwise your monitoring will not give you any data. So in his case, he's checking for the actual process being online, because otherwise it wouldn't work anyway. Mike?
Right, but we could also create a process monitor to keep track of that monitor, of that process.
Yes, and auto started based on a diagnostic recovery task.
Yeah, all the good stuff. It's just a matter of time.
That's it. That's it. All right. So
Well,
that was. I think that's on to
great,
the next.
Bob. Yes, it is on to the next. Thank you so much, Bob. You have once again proven that you can monitor anything with SCOM, and it's great to see. It's great to see that happen. Thank you so much for your session. It's also great to see all the training options that are available through TopCore, and Bob and his organization provide really second to none in terms of training SCOM, particularly with some of those operator roles that he was describing. So once again, Bob, thank you so much.